We're going to look at simplifying radicals with addition and subtraction, like radicals, unlike radicals. Uh, like radicals, we're going to treat them a lot like terms. You can only combine x with x, only combine y with y. You can only combine x squared with x squared when adding things together. So with radicals or square roots, the same thing happens. Uh, if I have a square root of 5 and a square root of 5, or radical 5, I can only combine those with themselves. So let's jump in. So here, 2 radical 5 and 6 radical 5. I want to change the thought process here. Instead of this, I want to think of it as if it's a 2x plus 6x. We know how to combine these. You're just saying 2 plus 6 gives me 8. Bring the x along for the ride. That's what's happening here. 2 plus 6 is going to give you 8. That radical 5, because it's in both groups, we leave it. It comes along for the ride. All right, and that's it. Next, radical 7 minus 6 radical 7. So, like having variables, if I just had x minus 6x, in front of this x, we have a number. It's a number that you don't have to show, but it's there, it's hidden. It's that magic 1. When you say 1 minus 6, we come up with negative 5. X comes along for the ride. Same thing happens over here. We have a magic 1 being multiplied in the very front. Now you're just asking yourself, 1 minus 6 gives you negative 5. Negative 5 what's? Negative 5 radical 7s. So when you have like radicals, things kind of move smoothly. But we're not always as lucky to have like radicals. Sometimes we have different radicals. Um, when we do that, that just means we have to create like radicals maybe. So I want to try and break my radicals up as much as possible. Square root of 5, can't do anything with, smallest number. Square root of 20, I can break that up into two numbers, one of them being on our perfect square list. What's the pair that we're going to use here? Well, it's going to be 4 and 5. And we still got that 3 in front. So that's gone. Okay, let's simplify this now. So 6 radical 5 plus, let's take a step back for a second. That 4 gives me a 2. 5 stays inside. We're still left with a 3 outside. So now 6 radical 5, bring that down. 6 radical 5, and we have a plus. Okay. Do we have like radicals? Yes, we do. 6 plus 6 gives us that 12. Radical 5 stays the same. Okay. So here you had one where we couldn't simplify. We only had to do the one. Now we got a lot of work that we have to do here. We got to break down each one of these. So two numbers multiplied together to give us 8. I like 4 times 2. Two numbers to break us up to give us 12. Now I could say 6 and 2, but square root of 6 isn't on our list. Square root of 2 is not on our list. That's not the pair that I want. Pair that I want, 4 and 3. 4 is on my list over there. And now 18, I can break that up into 9 and 2. Let's simplify each one. Square root of 4 gives me 2. The other 2 stays in. Plus 2 comes out. 3 stays in. Plus 9 turns to a 3. The 2 stays inside. Can I go one more step by putting things together? I can combine that and that. 2 plus 3, 5. We're talking about radical 2's. And this radical 3 just comes along for the ride. And that is simplifying radicals by adding and subtracting.